Okay, when you're doing this, double check too, down at the bottom right, and their domains. Okay. F times G, F divided by G, F of G. Okay. I saw a couple pencil smacks of I'm done. Anyone need some more time? Okay. You can always tell when someone's confident because they finish and they're like, get wrecked, math. I mean, I'll take tips. And if you didn't do the video, wait, you were gone yesterday. We didn't do anything yesterday. Never mind. Okay, there we go. I thought of something. You don't have to do it if you haven't done the video yet and you don't feel confident to. But I just got to make that clear for everyone. Remember, if you are gone for whatever reason, you aren't prepared or ready to do thing, don't do it. Okay, that's tests, that's daily checks, that's whatever. And you just have a conversation with me, and especially if it's at a grading period like today's midterm, I just leave that stuff blank. It doesn't count for or against you. I think it's dumb to put a bunch of missing zeros in a grade book and wreck a kid just because they haven't gotten to it yet. Okay, as long as you have a conversation with me, we're good. Fresh. Like, who does that? It's like putting the empty milk jug back in there. Okay. That's it. I still see pencils moving. Are we good? All right. Cool, cool. So, we have contestant 1. F times G means I will take x squared plus 3x minus 10. I will take x squared plus 3x minus 10. I will take something squared plus 3 by something minus 10. And G. G is x minus 2, x minus 2, x minus 2 is my input function. Max, if you're going to die, please do it out in the hallway. Okay. Less paperwork. Dude. Okay. This is the setup for it, but we have to make sure to... What? Oh. You just stopped all of a sudden with a deer in the headlights looking like, is my fly down or something? What's going on? Okay. This is the setup. And then we have to simplify. As we simplify, we make sure we're just not doing stuff like a freshman. X times the stuff is x to the third plus 3x squared minus 10x. Negative 2 times the stuff is negative 2x squared minus 6x plus 20. So we combine like terms, all that business, and get x cubed plus x squared minus 16x plus 20. And because that is a polynomial, polynomials are defined across all real numbers. I don't have to worry about the original versus the inverse. I don't have to worry about an input function restrictions, anything like that. It's just all real numbers. If you put, again, if you put the real number symbol, real number set symbol like this, or if you do negative infinity to infinity, both are cool. Contestant 2. Whenever I see a rational function, factor, friggin' factor, that's x minus 2, x plus 5, x minus 2. Be super careful here. Yes, these will cancel. Yes, your final solution is x plus 5. But the domain is not all real numbers. Why? Okay. So even though this is the simplified version of it, there is a hole back here that I still have to get rid of. So we're going to go from negative infinity to negative 5. No, negative 2. Looking at the wrong thing here. Negative infinity to positive 2. Words are hard. Can't touch this. And 2 to infinity. And downstairs, when you distribute or square, don't do like freshmen, that's x squared minus 4x plus 4, then plus 3x minus 6, then minus 10. So, x squared, negative 4x and 3x is minus x. 4 minus 6 is negative 2. Negative 2 minus 10 is negative 12. I know that it is factorable, okay? That's my answer. It is simplified, it is done. Okay, we have factored so many quadratics in our lives that when you see a factorable quadratic, it's like, you just kind of do it. Okay? You don't have to. In fact, if you put this in factored form, then you have parentheses. Parentheses indicate there's still operations to be performed, so it's not simplified. So leave it like this, and all real numbers again. Because not only is this a polynomial, all real numbers, but my input function was also polynomial, in this case a line. So in both cases, all real numbers. So we should have your answer, your answer, your answer, your domain, your domain. I'm going to combine the two all real numbers ones because that's just like, that's polynomials. That's what they do. It's kind of a gimme. Now, naturally, if you goof somewhere back here, it is going to mess with your answer, but 3 things and 2 kinds of domains. Any of the questions that we had with the homework were answered yesterday with our impromptu FUBAR day. I was really thinking we were going to go ahead and get 1-7 done, and then, oh wait, that's right, all the band kids are gone too, and half of my first hour was gone. So, it was a thing we had to deal with. I also thought we were going to get 1-7 done this morning. And there's a reason I am deleting that one and we're doing this hour for the backup video because, okay, so here's the deal. I'm exhausted, and y'all know when you're tired, you're on a hair trigger, and like something Algebra 1 level, and I got frustrated, and I shouldn't, okay? And I hope that you have a relationship with your teachers, and your teachers have the presence of mind to be human around you, and you hold them accountable. Y'all, if you got gaps in your knowledge, like, it's one thing if I literally just covered this 10 seconds ago, and then you ask me what it was. Okay, I can be a little grumbly about that. Also, teachers who do that all the time, give kids time, there is such a thing as ADHD. It sucks. But we also have to be cognizant of the fact that the last 3 years have been a dumpster fire. Kids have been gone all the time. We've had kids who have moved back and forth, kids who have transferred districts, kids who were online for a while, kids who were absent for 3 weeks straight during the middle of a section. There are going to be gaps and holes in our knowledge base. And in the last 3 years, I'm betting the lot of you took algebra. So we ran into a thing that I'm pretty sure was one of those holes. And I got grumpalicious about it, and I shouldn't have. That's on me. That is not on them. That's not on you. Okay? So hopefully it goes better, especially now that I'm running into it knowing that this might be a possible bump in the road. Okay? So, you. Y'all probably don't want to do basic linear inequalities.
Still on basic linear.
That's my low algebra. That's like algebra 0.6, and we run through the bare basics with them to make sure they get what they need for a diploma. Like there are set minimum standards we need for a diploma, and these are kids who would struggle with math. So I run them through the basics. No. They had algebra half last year. We're doing it all again because they don't remember a thing. By the end of the year, we'll get to quadratics, and I'll show them basic factoring and quadratic formula, and that's it. Like they'll never complete the square. They'll never plot by perfect square steps. They'll never do a square root graph. They're never going to graph rationals by anything but table. Like we water it down and say, this is the bar. You have to be here. This is what you need for a diploma. This is what you need to go into a low-level geometry so that you can go to a tech school and still further yourself in education. And I've had that class for 8 years, and I love it. It's great. Yeah, kind of like college algebra is algebra 2.05. This would be like algebra, not even 1. This would be like algebra 0.6. It counts as the Algebra 1 credit because I am still going into exponents and quadratics. We're just watering it down. So, but yes, we are still in inequalities. We have been for the last 2 weeks. So, let's see who was paying attention the other day. What's the difference between a relation and a function?
The function is like when you do the opposite and still get x out. I don't know how to word it.
Okay.
Like when you plug the function in for the other function, you get x.
Oh, that's how we're going to prove that these are inverses. That's the identity. Okay. A relation is just anything that maps input to output. Any equation. A function is a special one, where every input has one output. I press the button in the middle of my steering wheel. It lets a guy in front of me know to rethink his life choices. I press the button again. It better make the same sound. If instead my windshield wipers start flapping, that is not a functional machine. The same input had 2 outputs. Okay? So functions are special like that, and we know that something is a function because it can pass a vertical line test. Okay, this might be a little hard to see because they're overlapping, but a parabola would pass a vertical line test, right? Okay, it'll take off really sharply, but it will still pass that vertical line test. So an inverse relation versus an inverse function. An inverse relation is when I swap domain and range. Here, move you over here. Okay, I swap my domain and range. So you remember seeing like the table of x's and y's? You would just take and swap your x's and y's. Because domain and range are typically x's and y's. An inverse function is when I do that same stuff and it's still a function. So for example, this, if I swap all of my x's and y's, like say this is at, say this is at 3, 7. Now I'm going to go to 7, 3. And that's why it looks like that parabola is on its side now. Okay? Well, this is the original function. This is its inverse. Does it pass a vertical line test? So that is an inverse relation instead of an inverse function. It's not special. Okay? Kind of the whole finger thumb thing, right? All thumbs are fingers, but not all fingers are thumbs. Okay? You all remember back to geometry, conditional versus biconditional statements? If, then. That's a conditional statement. I set up the condition, I tell you the result. A biconditional statement, you would write if and only if, because it works both ways. Okay? Inverse relation, inverse function, not necessarily if and only if. Not necessarily one means the other. Okay? Y'all teenagers, you've had arguments with people where just because I'm blank doesn't mean that I'm gonna blank, right? Like insert characteristic means I'm assumed to do thing. No, it doesn't work that way. Just because I'm a jock doesn't mean I'm dumb. Like, no, some the smartest kids in the school are top athletes. It's also the other way around. Some of our top athletes are really not good at academics. Okay? It works both ways. So the easiest way to tell that is
I'm not.
shade. Um, so here's the deal. If I swap x's and y's and everything gets flip-flopped, what's the opposite of a vertical line test? Horizontal line test. That's how you tell if something's got a function or an inverse function or not. So if it passes a horizontal line test, then its inverse is a function. I'm just asking, like, will it be or not? So again, like that parabola. A parabola fails a vertical or a horizontal line test. So that means when I find its inverse will fail the vertical line test. That's how you test it. It means you don't even have to find the inverse and then test that. You can just look at the original and say, all right, will it work? Nope, it won't, so I'm not going to find it. Ha. Okay, it's a way to kind of just tell if it's going to be a function or not, whether it's worth bothering doing it. Do y'all remember the notation for them? This is why I kind of go off about function notation. This is the name of the function, remember? Name of the function, the input. Then I get some rule, some expression with variables, and the result at the end is y, which is my output. Okay, I got to make that distinction because the notation for inverse is this. And that can get confusing to kids. In fact, I hated this for years. From the time I was in high school all the way through, I had been teaching for years, and I still just hated it until I really wrapped my head around the idea that this is on the name of the function. And the reason I didn't like it is because what does a -1 normally do?
Make it like 1/x.
It's a reciprocal, right? So there's kids who will see this and they'll incorrectly think I flip it. But I don't because it's on the name of the function, not on the rule of the function. So it's like, if this is okay, this is Fred. This is anti-Fred. Okay, this is like your evil twin in another dimension kind of thing. Okay, anti-Fred. It's the inverse because I put that -1 on the name of the function. And it can sound like you're arguing semantics, but boy, does that make a difference. Okay, so that we're asking, does the inverse function exist? Does anti-Fred actually work for us? Pretty simple. Do you know what this graph looks like?
Yeah.
What does it look like?
V left one.
It's a V. Is a V gonna pass?
Right.
Attaboy. Is a V going to pass a horizontal line test? No. So since this fails the horizontal line test, I would say that the inverse function doesn't exist. There is no anti-Fred. Okay? Because when I try to swap all of my x's and y's, it's going to look like this. Yeah. Vertical line test is whether it hits it once or more than once. Okay. Ask the question. Don't just chase the bus. Okay. All right. Cubic. What do cubics look like?
Squiggle.
The problem is it can look like this or like this.
Yeah, what the sus?
And one of them passes the horizontal line test. The other
Oh.
doesn't.
It looks like the second one because it has an x squared in it. Yeah. Maybe.
I don't know.
Okay.
Because remember, if this can factor down into something cubed, then it's transformation form. Do y'all remember factoring polynomials? Okay. I don't want to factor polynomials yet. That's section 2.2 and 2.4. Instead, I want to just dump this in my calculator and look at it. So, dump it in your calculator and look at it. Will it pass the horizontal line test or not? Okay.
How can you tell?
Wait.
Oh,
Yeah. Never ask, dude. Just go. You type it in, you hit graph, and sometimes it can be hard to tell if that has a little ripple to it or if it's an inflection point. How do I know for sure?
Graph table.
Graph table, I can like trace it, right? You can trace it and you can look at the table in tiny little increments and see, all right, I'm checking, does y continuously go up or does it ever backtrack? Oh.
It did.
Wait a second. I'm at negative something, negative something, negative something, negative something, positive. Oh, wait. No, that's negative. So almost 0, and then it goes down. Or does it? Look at what's at the end of it.
That's like 0. That's even more 0.
Okay, it's in scientific notation. So that's 0! And then just a hair above 0. So it looks like it's good. I can also zoom in on that value, and I can just keep making it bigger and bigger and bigger and zoom in on it and see if it ever has that tiny little wave or not. And no, it's an inflection point. Okay, so since it's an inflection point, that means it'll pass my horizontal line test. I'll say the inverse function exists. We don't have to find it yet. I just want to know if anti-Fred is real. Okay?
How do you know if you use the horizontal line test or the vertical?
Okay.
Or inverse?
A vertical line test, why that's all of a sudden lowercase, a vertical line test is for function. A horizontal line test is inverse function. Exists. Vertical line test is this thing I'm looking at right now a function. Horizontal line test, will the inverse be a function? So that'd be like, this is a function. It's going to pass a vertical line test. I'll even put like a, like this. This is a function. The horizontal line test, is asking, will the inverse be a function? Because if it fails the horizontal line test, that means when I go to make my inverse will fail the vertical line test. Horizontal line test says, don't bother making the inverse because it's not going to be a function. Like, it's not worth it, because if I hit two different x values along this y, then I will hit two different y's along this x, because I'm swapping x's and y's.
So you test with vertical to see if it's a function.
You test the horizontal to see if it's a function. Decide not to get at it.
No.
The inverse function is when it's
Okay.
like,
That's just weird.
Vertical line test, is it function now? Horizontal line test, will it be a function after I inverse? Now versus prediction. Okay? It's just now versus prediction. Because it really sucks to go through all the work of finding the inverse, and then it turns out you shouldn't have anyway because it wasn't going to exist. Okay? Both of them. If you know what the function looks like, then all right, just sketch a graph and tell me yes or no. But if you're not sure what the graph looks like, you should probably plug stuff in, look at that screen and say, will it pass my horizontal line test?
Number 1A. Hey, wait.
should be pretty quick, right?
Yeah.
It's a parabola.
Yeah.
Parabolas
Don't exist.
fail the horizontal line test. So the inverse function doesn't exist. The inverse won't exist. What's this guy look like? Have vertical asymptote at 0, horizontal asymptote at 0, and then keep doing a bunch of 4 divided by number. 4 divided by number. So looky like this. Again, it curls along an asymptote. I know those look like it's going to be at 0, so it would fail horizontal line test. But just like the parabola, as it goes further and further up, if you zoom in on it, it's got enough of a curve there. Okay, so this one, yes. The inverse function of h does exist. Okay, so again, we talked about the notation, right? You're swapping domain and range. The domain of f gets to the range of f. When I swap things, now the range of f is now my domain for my inverse. I am swapping. That's important when we're finding inverses because say I've got a graph that's like I have a vertical asymptote at x equals -2. I have a horizontal asymptote at y equals 3. Say I had a graph like this. Whoop. Then its inverse is going to swap x and y. So it also swaps the domain and range. The domain would be x can't equal -2. You do the union thing, can't touch this, blah, blah, blah. The range would be y can't equal 3. So then when I go and find my inverse, now x can't equal 3, y can't equal -2, because I'm swapping domain and range. I'm swapping x's and y's. So sometimes you're going to have to look at the original to figure out what the domain and range are of the inverse. Just like with composition, sometimes we had to go back and look at my input function just to be safe. Okay, so we are swapping domain and range. That also tells me how I find these things. Step 1, check if it even has an inverse. Like, the first thing you should do is just horizontal line test, should I even bother doing the math? Step 2, remember that we said f of x equals a rule equals y? So the first thing I should do is replace this stuff. There's now a rule that has y's in it equals x. I will swap my x's and y's, okay? And then I solve for y, get all the way down to the end, and get inverse function of x is whatever my new rule is. Okay, swap x and y, solve for y, write it in the correct notation. And next to this, realizing how much I didn't say first hour just because I was all frustrated. When you do that, you have to check your domain and range. Because when you swap your domain and range, you are swapping x's and y's. When I swap x and y to make my inverse, I better double check my domain and range at the end. Okay, the specific example that messes with us is our quadratics to square roots. Remember that square roots, we only have half of the graph instead of the entire graph. We don't do plus or minus. That means when I go to make the parabola, since square root only looks like this, I'll only have half of the parabola. Okay?
Kind of cool, huh?
Now make a.
Now,
It's better than him like taking writing
I've
like
always
stories in there.
You know what I found interesting? X to the 69th is like the weirdest graph ever. And I didn't even mean to do it. It like goes up and then over and then just all the way up into it.
I think, yeah, boy.
What do you mean you didn't mean to?
Like I guess I just force a habit.
all right. So, because this was to the max, because I know that this was the problem we had first hour, I want to start over here. Okay. So, step one. I know that the function of x is the rule with x gets me a y. Y'all, is this going to have an inverse or not? Should I even bother doing math? If we don't know, we better look. What does this graph look like?
All it is a little line, so it passes.
Okay. Remember, it goes right 4 and then shoots off to the wild blue yonder. Okay, so it starts at 4, 0. Right? The domain starts at 4.
Yeah.
4 to infinity. The range is going to be from 0 to infinity. Wait. I should remember that. Okay. I'm going to swap x and y. All right, now go get y by itself. Solve. Solve for y. Y equals junk. What do you do first?
Oh, I
Yeah.
how to do these.
You square both sides. Almost.
No, x squared equals.
I forgot.
Add 4 over.
I remember. I was
X squared plus 4.
Okay, I can't leave it like this.
You can factor it. It's
No, no, no. Well, I can. But do you remember that it's x plus 2i, x minus 2i? Because it's sum of squares?
No.
Polynomials are coming next
I
chapter.
didn't remember that because I thought it was just when it's a negative that you put the I in.
Well, it is a negative. It's negative 2.
Difference of squares is plus or minus conjugates. Sum of squares is plus or minus or complex conjugates. So if that threw you for a loop, A, y'all just took algebra 2. B, we'll get there. We'll do it again. Okay. No, I mean you need to write it like this. It was almost done. You need to wrap the present.
Okay.
You don't just buy it and leave it in the Walmart bag.
Okay.
Okay? I mean, sometimes you do, but. Okay. So here's what I mean by we need to keep an eye on this, on the originals, domain and range. Look at this guy. It's a parabola. What's the domain of a parabola? All real numbers,
Yep.
normally. But this guy had a domain of 4 to infinity and a range of 0 to infinity. I just swapped x's and y's. That means I swapped my domain and range. So I can't leave it like this. I need to take the range of the original and turn that into the domain of the inverse because I swapped x's and y's. Now, Look at the directions. I think I talked about this the other day. I'm not sure.
We did this.
The difference between state the domain versus state the restrictions to the domain.
That just means what it can't be.
So state the domain is like, tell me the entire guest list. State the restrictions to the domain is who's not allowed. In this case, my y's, okay, my x's were greater than or equal to 4 and my y's were greater than or equal to 0. That means they're going to swap for my inverse. X has to be greater than or equal to 0. I swap domain and range. So sometimes you're able to look at your inverse function and you can tell what the domain is pretty easy from it. But you better go back and check. Is that actually the domain? The reason for that is when I graph these, can I say that this has an inverse of this?
No.
Like there's literally an entire chunk missing here, right? Well, okay, fine, I'll just put this down here. Well, now this isn't a function. So what we do, we restrict the range on a square root, which means I need to restrict the domain on the parabola so they'll actually be inverses. Okay? So you swap x and y, get y by itself, double check your domain at the end. This guy, this is where we ran into problems. The function of x gets me the rule with x, gets me y. I'm going to swap x's and y's. I want to see if you can get y by itself. When you see the trick, hopefully all of algebra half or 1 should come flooding back to you. But I want to see if you can get there now. Who remembers stuff? Who's got big brain? Who remembers how distribution and factoring work? Combining like terms work? Can you get the y by itself?
You need to combine them, right?
Yeah, you can't say y equals stuff with y. That's like defining the word using the word.
Maybe.
Try stuff. I just want you to try something and see if you can figure it out. Wow.
Kaboom.
Why? Oh, you can't do it because you only multiply it conjugate, and it's like an I. It changes. I squared and negative 1. In there. Doesn't work. And if y squared minus 4.
Okay, the first problem we have is we've got y on denominator, right? How do I undo this is on my denominator? Okay, run with it, see what happens.
Just multiply by it, or do you multiply by the conjugate?
Not the conjugate. I'm not trying to rationalize one thing. I have a equals in between. I have a balance.
Oh, you just this y. Oh,
Also, basic.
full looped right there.
Also, do you remember basic proportions that you can cross multiply?
That's what I did.
Okay. So I wrote them both to show you, look, we're going to get the same thing. It's just which side it's on. Okay? But now, can you get y by itself? We took care of that denominator. That was a problem. Now can you get y by itself? This is where I tried showing like basic arithmetic to them and the definition of combining like terms, and I ain't gonna lie, I got heated. Like I'm I am genuinely embarrassed that I got that frustrated. I want you to try stuff. Try stuff. Talk to your neighbor, argue it. I want to see who can figure it out.
Well, I mean, yeah, what happens if I divide y by y? I just eat
Oh.
y.
But you better remember that what you do for one, you do for all.
So it doesn't work because
Y divided by y is just 1.
okay, well, it's one y. Because if you divide one side by y, you have to multiply it into like -1 over y, right? And like, I don't know.
That's the problem, is if you try to divide by y, you you end up with y on a denominator. Right? If you're trying to get this guy by itself, you're like, fine, gone. But math is communist. What you do for one, you do for all, or multiplication is. You got to do it for all of them. Well, now you've got 1 minus 1 over y is x plus 2x over y, and now I got y's on the denominator again. Oh, I know how I'll deal with that. I'll multiply by y.
And then you're right.
Yeah.
Okay.
So it's not a function.
Oh no, it is. And when you see it, hopefully it's you want y's by themselves, right? Start by getting y's on one side. Y minus xy is 2x plus 1.
Oh,
Or xy minus y is negative 2x minus 1. You see how they're the same thing, it's just one is the negation of the other? Okay?
you can take a y out of that one.
Just divide by x. But if I divide by x here, I divide by x here, I divide by x here, I divide by x. Good, it's the same thing! How do I do it? There! There it is! And that, like, I just couldn't, they couldn't wrap their heads around this, and I know I was probably saying it wrong because I was just, like, bamboozled that we didn't understand this. Yo, take a Y out.
I actually said that at the beginning.
No, I'm here.
Chase. Back me up.
Take a Y out. Now I know they look like they're just, it's kind of like the Spider-Man meme, they're just pointing at each other, right? They look very, very similar. In both cases, you'll divide by whatever thing is smack next to Y, right? Hmm? Y times 1, negative 1 times 1. Oh, they are the same. One is literally if I take one of these equations and just multiply everything by a negative, I'll get the other one. Like, they're the same thing. Okay. So this guy, I divide, I get y is 2x plus 1 over 1 minus x. This guy, if I divide, I'll get negative 2x minus 1 over x minus 1. You see they're the exact same things, it's just everything was multiplied by a negative. Okay? So here's what I tried showing them, and it caused problems. Back here, this is the difference between I understand the concept behind algebra versus I know how to follow the directions in algebra. This is no different than no, I'll do that. They're solved the exact same way. Get y by itself. What would you do?
Subtract by y and
You subtract y over to the other side, right? But, and this is where I started not simplifying things along the way to show them it's the same thing. Subtract y, subtract y. I had kids trying to say that this was just 5.
Ooh, that's
I think at that point they were just so lost that they forgot how math worked. And when you get confused, it's like when you write the same word 20 times, it no longer looks like a word.
Yeah.
Like, go ahead. I dare you.
Yeah, it happens to me all the time.
By the end, it's like lion, lion, like, huh? Right? You just keep writing the word, and no matter what, every spelling now looks incorrect. I think they were just at that stage. When I do this, isn't this a 1 in front of y?
Yep.
Yeah. You normally write 4y because you can combine like terms. Isn't it technically 5 minus 1 y's? I tried showing them that. Like, look, it's the same. And it broke their brains. And then everything just kind of spiraled after that. Minus 2, minus 2. Normally, we would say that's negative 3, wouldn't we? Couldn't I just leave it as negative 1 minus 2?
Yep.
Couldn't I now divide by ugly? Getting y is negative 1 minus 2 over 5 minus 1. Because what if they're not like terms? Like, you have done this process before, it's just you can't combine the like terms now. Okay? But once you see the factoring trick, are you good? Okay. Like this is where you get into upper level maths, and I said you just prove why math works. That's an example of why math works, is I'm just distributing and using distributive property. Okay? Each of these, set thing equal to y, swap x and y. Okay? I think it was, honestly, I just got super excited about it, and they weren't following along. It's like when someone tries to show you a new game. And like, oh, dude, and then you do this, and if you do this combo, then it's gonna like put them up here, and then you're gonna. And you're like, shut up, dude. How do I reload? Okay. I think the combination of that plus COVID gaps in knowledge is we just kind of had a big old hit wall
So once
first
you
hour.
flip it, you want y by itself.
So swap your x's and y's and then
Get y by itself.
get y by itself.
How do you do cube root again?
Cube root will either be in math or it will be in alpha window shortcuts.
Wait,
We did cube roots, right?
Yeah.
that's like,
So it's just the like, it's the thing.
Did we just unlock something for you?
yeah, all of like
Cube
algebra
root.
2, I was like, well, I guess I just have to solve this by myself because I would just assume that we all knew that.
Is cube
I'm sure
root
Chase
like
knew though.
like x cubed flipped?
Hmm?
Yeah, you just
So
go
the
into math
inverse
and
is
it's
just
right there.
x
Yeah.
cubed.
Yeah, I forgot.
So that one's
There's
inverse
an
is
x one if you go to 5.
Cube root. Yeah.
You can put any number.
Oh, that's interesting.
Yeah. If this one looks like this,
X plus.
then its inverse will look like this. Because they should be a reflection down the line, y equals x.
So they do exist though. So we're just proving that
Well-
there is an inverse.
No, you go find the inverse.
Wait, this is the inverse.
Do I need to zoom out?
Y equals cube root of x plus 6.
You better write that in inverse notation, sir, and then tell me the restrictions to the domain.
Why do
Finish
you
the
have-
problem before you pat yourself on the back.
What is,
You have to write it like this.
oh,
And then double check your domain for it.
Why do you have the purple line there?
Purple line is 2a.
Oh, wait. Really?
Blue is what its inverse will be.
Oh, yeah. So this is its inverse. Might need to zoom out, but
Yep.
still negative infinity to infinity. Yeah.
it makes a ton of sense. It literally just flags line.
Well, because exponents are more powerful than multiplication. So a cube something takes off really fast. Okay. Exponents compared to multiplication and addition would be like souped up, like a Toyota Supra racing car compared to a semi. The semi got more power, but it's going to take a longer time to do it. Whereas that little driftmobile zing,
Whoa.
takes off.
X plus 7 over x.
So
What
where
the
do we
heck
go
kind of
from
graph
this
is that?
point?
Why does it just stop?
Because sometimes we gotta be smarter than the calculator. Zoom to standard, zoom 6.
Oh.
You were still really zoomed out.
Where do we go from here?
Also, that is not the right graph.
Oh,
You just did x.
heck?
You gotta put x plus 7 in parentheses.
I just added them.
Okay.
So where do we go from here once we basically get to this point?
Factor out the y. That was the key to
Oh, I
those
need to
problems.
So I don't know why I'm so confused. So take y out.
Yes. So if you take a y out of this, you get x. If you take a y out of this, you get a -1.
And then
Divide to get y by itself.
oh. Y y equals 7 over x minus 1.
How'd you get to that? What do you do once you get x equals what? 7. Alpha window.
Okay. You know what? I'll back up to these. Here. This guy, I set it equal to y, swap x and y. Negative 16 plus y cubed is x. Who's next?
And then cube root.
And then cube root. And I think y'all be okay with me just shortcutting over there and saying inverse function of x is cube root of x plus 16.
Oh, I thought we just put.
Okay, so domain. Look at the after product.
So there's a hole at the asymptote,
Um, why not? It'd be like when you're doing domain, there's certain things that you can't have, right? If I get a cheeseburger, I cannot have mustard or pickles on there. Sometimes I can look at the end result. It's disgusting. Okay. Sometimes I can just open the bag and I can smell if there's something in there. Sometimes you can look at it and say, there's an X on denominator. I know there's a gap in my domain. Don't you still check to be sure? I still want to check the domain and range of this guy to make sure there's no goofs. So like this, do I see an X on denominator?
No.
Do I see an even radical?
No.
A logarithm? Okay, this guy says all real numbers. Come back here, and this guy had a domain of, it's a polynomial, all real numbers. Range, what's the range of a cubic? Also all real numbers. Didn't it start down at negative infinity and then go to positive infinity? But I had to double check. I'm still going to open that burger and check. No one wants to bite into a burger and find something they don't like. Okay? I'm still going to come back and check the range of this guy to be safe. Okay, this one. Set an equal to y. Swap x's and y's. Y plus 7 over y is x. I'm going to cross multiply. I like cross multiplying. You can multiply both sides by y. It doesn't matter. I get xy is y plus 7. If I want to solve for y, then I need all my y's on one side. I'll subtract this guy over. But we have to understand that xy's minus 1y's is x minus 1 y's. So that's how I would write it in terms of combining like terms. But since that breaks some kids' brains, instead we'll say, all right, just factor out the y they have in common. Okay? Both are going to have the same result. They're just different ways to think about it. And then finally, I'll divide by that and say inverse function of x is 7 over x minus 1. Okay? So sometimes I get my food, I open up the bag, I can smell onions in there. I see that I can't have x equal to 1. I see that right out of the gate. So I think that my restriction is x can't equal 1. Notice that it says state the restrictions. It doesn't say state the whole domain. So I can just say not 1. But this guy, if I were to graph it, there's a vertical asymptote at 0. There's a horizontal asymptote at 1. There's a x-intercept back at negative 7. We're going to review all of this in section 2.5. Like that. So the original has a domain of x not 0, a range of y can't be 1. So it should make sense that if the original had y can't equal 1, then the domain of the inverse will be x can't equal 1. Okay?
Wherever the asymptotes line up is where
In this, on these type of functions, yes. Remember, we got lines, we got quadratics, cubics, quartics, we got reciprocal functions, greatest integer functions. We got all that stuff that we can mess with. So sometimes it's obvious. Sometimes I want to double check. Okay? Who got caught in the trap?
How do we know that? Oh, the freaking
Step one.
yeah.
Vertical line.
Horizontal line test. John.
Step one, the horizontal line test. If I make my window go far enough out, I'm going to see this graph.
That's so weird.
This one looks like some guy going, huh? Okay. Now, I could have seen that, known that it fails a horizontal line test, and just said, nope, doesn't exist, done. But I want you to see what happens when you go all the way to the end zone. You'd say this equals y, swap x and y, green. X squared, nope, y squared. Y squared minus 20 is x. All right, how do I get that y by itself? Okay. And then? Add 20. And then? Oh, I'm sorry. Didn't we just put a radical there? We just put an even radical there? So when I put any x value in, I'm going to get a positive and negative variant. It will fail the vertical line test. This is not a function. So the inverse function does not exist. Now it is an inverse relation. We have a whole chapter devoted to these later, conic sections. Like, yes, you will graph these. You can graph parabola on side. Turns out there's a bunch of stuff about it we never told you. You're like, wait, what? We know parabolas. Like, what's that?
Line symmetry.
Okay, axis symmetry does still exist, but do you know that there is also a directrix and a focus and a latus rectum?
I do now.
Okay, yes, it's called the latus rectum, not lettuce rectum like the vegetarian having the squirts or something. Like it means it's literally Latin for how wide is the opening. That's why it's called a rectum. Okay. So, like, those things exist. Y'all kids been laughing at that in Algebra 2 and beyond since the beginning of time. Okay? You're not the first to say rectum. Okay? I want you to show me. Show me we got that. I need to know we got that. Because honestly, I biffed that hard first hour. I feel bad about it. I want to make sure we got this.
Do we graph it before we switch to X and Y's or after?
You graph it as is right now to double check if it's even possible. Does the current equation, the current function, pass the horizontal line test? What the? He's mini Jace.
I was 7th grade.
He's so iddle.
That's how you were in 7th grade. I thought we looked so much bigger in 7th grade. We were so tiny. I never smiled at my pictures, so.
Oh yeah.
Mugshot.
Was it 2 weeks ago? I think Game Club was rolling through old pictures and videos and stuff at lunch.
Mm-hmm.
Saw this young man at the ripe age of like 12 in the background of one of our videos. He used to tag along with his brother to Game Club events. Some of the nerd herd, I've known them for 5, 7, 8 years. Well, I remember when you were just a pudgy little Oompa Loompa.
Whoa, you could factor.
You'll factor out a y. Remember, swap your x and y first.
X is not. What is X not going to be? It's not going to be. It's not going to be. It's not going to be -2, right?
1/2, right? 1/2.
I don't know. That's what I'm thinking. But I got the universal. It's 7x. It's 7x plus
Oh,
1 divided
2.
by -x.
Yeah, you're right. You're right. It looks right.
After you take this y out, so is it just x
And
plus
so you
7x
got,
is left, or
No, subtract
-2.
him over. Y is on one
Just
side.
2.
minus 2y?
7x
Yep.
plus 1.
And then move the 7x to the other side.
So you get x
xy minus 2y
equals 7x minus 1.
negative 7x minus 1.
Y.
Okay.
Okay. Minus
Looks like we're doing all right with this. If this equals y, then we'll start here. We'll start at red this time. We'll go with 2y plus, no, Batzel. Okay, over y plus 7 is x. I'm going to put this over 1 and cross multiply. I will be at xy plus 7x is 2y minus 1. It might be completely flopped of what you have. That's okay. At the end, it'll be the same thing. We'll just have the negation. Then, if I need to write out this part, I will. Minus 2y minus 2y. Like, if we got to go old school, if y'all need that dividing line down there so that we don't screw up which side things go on, okay, this is what I do with my algebra. Okay. Do I need to say minus 7x like this? Showing that this zeroes out and this zeroes out. X y's minus 2y's. What if this was 5y? 5y's minus 2y's is 3y's. But I could just say 5 minus 2y's. So I can also say x minus 2y's. These two got nothing to do with each other, so they're just going to stand awkwardly next to each other. Divide by x minus 2, and you're there. the inverse function of x is negative 7x minus 1 over x minus 2. Or, if you multiply numerator and denominator by negative 1, who had instead 7x plus 1 over 2 minus x. Okay? They're the same thing. Well, negative x plus 2, 2 minus x, same difference. Okay? So either of those is fine, and sometimes you get your order, you open it up, you smell pickles. I know that x can't be 2. Come back here and double check. The range of this thing, wrong side. Okay. This guy has a vertical asymptote at x equals negative 7, so that's the gap in my domain. And it has a horizontal asymptote at y equals 2. So if y didn't equal 2 here, then x can't equal 2 here.
Gucci.
No cap.
You went no
Okay.
cap, though.
Are we good with this?
Yeah,
Like, we're solid? Okay.
pretty
We'll stop there because that's as far as first hour made it due to our debacle. Okay? And I do got to be clear about that.
Third hour on top.
That is on me because I got frustrated. That is not on them. Okay?
Yeah, third hour.
He's like, it was.
Yeah. That's on me.